Okay, all right, here we go. Let me test my go. Okay, all right, welcome everyone. Seconds. All right, so we're getting started with lesson 5 of our fundamentals mini boot camp. Super excited to have you guys all here. Today is we're getting into some of the more advanced JavaScript topics. Today's a little bit more of a mixed bag. We're going to be covering instead of like one giant topic, it's going to be just kind of a bunch of little smaller ones, but that can all get a little more complex. And so it's a lot of stuff. But it's really important material for you to know and understand. So, some of these topics we so for example, like this keyword, and we're going to talk about a thing today called callback functions. We'll be diving into a lot of that in depth week 1 in our full-time course. So so people have been asking about the full-time course. I'm pretty sure the February class is all full at this point. There might still be a little bit of room, so if you're interested, be sure to DM me or Austin tonight. And then also, but then we do have spots available in our March cohort as well. So if you're interested, we would love to have you come and attend. Again, it's free up front until you get a job. We do teach full stack software engineering and server side stuff, web application stuff, computer science fundamentals. You spend tons and tons of time coding. Our first group graduated last Friday. 25% of them have jobs so far within a week. We a little over a week now. One of them got a job at Uber, which is pretty exciting as a mobile developer. So anyway, it's a lot of fun. We'd love to have you guys come and learn with us. Our goal as a company is to make education as accessible as possible, and to create an extremely high quality education and provide it to everyone who can physically attend. All right. Okay, so let's dive in, and I'm going to cover a couple different problems from the last homework assignment. For the sake of time, I'm not going to cover all of them. Last time it went a little long when I went over every single one of them. So I'm just going to talk about 2 or 3 of them. So if there's one in particular that you would really like me to look at, message it in Slack. The add calculate discount price method, we'll go over that one for sure. There are a bunch of questions about that one. This one was a little trickier. But yeah, so we'll probably do 3 or 4. I'll do this first one. So make cat, create a new object with the name property with the value set to the name argument. Okay, so when you're reading these instructions, you have to try to read these as literally as possible. And the computers are super, super rigid and strict, and so everything has to match up exactly. So like if this string that you're returning, on the function on the object, if that's a lowercase m, the whole thing doesn't work, or the tests won't pass. If you leave off the exclamation mark, it's not valid. It has to be an exact match. You have to return the object. So you have to read it very literally, and this is hard for beginners to really get into that mindset. You have to think about this stuff very, very literally, and you have to be extremely precise and nitpicky with following directions. And most of us are very casual, and so it's a little bit of a change in mindset. So we get a lot of question about make cat too. That's a question that from our pre-course work, I generally get a lot of questions, people asking about this one. So create a new object with a name property with the value set to the name argument. So name, an age property to the object with the value set to the age argument. So this is the name and age arguments or parameters. Add a method called meow that returns the string meow, and then return the object. Okay. So a couple different ways you could write this. This is one of them. I'm just going to create the object like this. enter down onto another line. And so in our function, the only thing we're doing is returning an object. And then now I'm going to define what that object looks like. So it's going to have a name property set to the name argument. So this name right here is going to be a key on this object. This name right here is going to be the value, or this, it's going to reference what this variable references. Let me zoom in a little bit more. All right, I'm going to do the same thing with age. So if, for example, name was Ben and age was 15, then what we'd have here is this object would have a key of name on it with the value of Ben and an age of 15. I'm not actually 15. All right, so name, age, and then now let's do a so add a method called meow. So again, this is just a function that we're putting on the object. And so I'm going to call it meow. That's the property name. And then we're going to write our function in like this. Just going to put the function directly on the object. So meow, and meow is going to return the string meow. So I'm actually going to copy that down to ensure that it's pasted in exactly, and then return meow. So then later, so down below, like if, or the way this is being used in the tests is we can go const cat is equal to make cat poofy and 3. And then now we can go cat dot meow. So, and then this right here would return the string meow, and you'd have to then pass that into a console log to be able to see it. But this right here is so this right here is down below. This is how the function that you're making would actually be used. This is how it's being used in the tests behind the scenes. But it's a function used for making cats, and the idea is that you can make lots of different cats that would all have different properties on them. So we could do cat 1, cat 2, and give them different names and different ages. So we're using this to construct an object. This function constructs an object. Okay. All right, so let's see, delete. So this new user here is very similar to the make cat one. It just doesn't have a function on it. Okay, verify password. Yeah, let's do verify password real quick. So check to see if the provided password matches the password property on the user object. So we're given this password, and we need to see if it matches the one on the user object. So this would be like a common type of a helper function. Like you would actually write a function like this on your server code. When if you're writing a server, you would have something that would compare to see the password that you had saved. There's hashing and different cryptography things we do there to make them secure, but ignoring all that stuff, we would, we're just going to compare this password to the one on the object and see if they're true. So what we can do here is, you can do if user.password equals password, return true, otherwise return false. So you do it like this. You could actually simplify it and just do return user.password equals password. Because what the second thing is going to do is this whole statement right here is going to evaluate to true or false, and then you would return that. So this right here is actually equivalent to all this stuff right here. We don't need to explicitly define an else here because we have a return statement inside of the first if block. We will never, if we get into the if statement, then the function is going to end. So the rest of the function is essentially treated as an else statement. Okay. So you can use user.password. Someone's asking about bracket notation. You could also do password like that, but that would also be valid. But but we generally prefer to use the dot notation unless you can't. So this right here, this would access a property called password on user. But so what it would be is like the user.password would be, or user would have a bunch of different properties on it, and then password would have some stuff on it, and then password would be some string, and then we have another password that maybe they submitted when they're logging in again. We need to compare and see if the password they just submitted matches the one that was saved. All right. This one's just like that one, but you're actually just going to override the original password. Let's see, add friend. Okay, let's I'm gonna go over this one, add calculate discount price method, and then if we have time, I'll go over some other ones. Okay, so add calculate discount price method. So we're going to add a method to the object. So store item dot calculate discount price. Calculate discount price. Okay, so this is a method. So we set the property equal to a function. Okay. All right, calculate discount price. So I want to make sure that matches exactly, and it does because you see it kind of highlighted it. My editor highlighted it automatically. So this method should multiply the store item's price and discount percentage to get the discount. The method then subtracts the discount from the price and returns the discounted price. For example, price is 20, discount percentage 0.2, discount price is 20 minus 20 times 2. So, and this was a very real type of a method that you would have, on in your code, like calculating the discount price for something. I mean, this is a very, very real type of thing that you'd be doing. So what we'll do is first I'm going to calculate the discount. Discount is going to be equal to, and then if you remember when we talked about this, we're going to use the this keyword. And so, because again, this function is going to be set on the store item. And so this will have its context dynamically set. So it will match the object that is using this method. So I'm going to say this dot price times this dot discount discount percentage. Okay. Price and discount percentage. Okay. And now I'm going to go return this dot price minus discount. Okay. You got the price times the discount percentage, and that gives us the discount. So, because essentially what we're doing here, so if the price is $10 and the discount percentage is 0.2, so if we add 10 times 0.2, and so we multiply that, and then that would give us 2, and so that's the discount. So here we'll take 10 minus 2, which is equal to 8, and then that's what we return. So 0.2 would be 20% off. So $10 item times it by 20%, that gives us the amount to be subtracted. So $2, and then we're going to subtract. We're going to take price $10 minus $2 and return it. So one way you can do it, again, different ways you could write it out, but this is an example of how you can approach that. Okay, this one's trickier, and a lot of this is getting used to the vocabulary, and this takes some time to get used to this. So just working through the practice, asking questions in Slack, that's the best way to get through this. Okay, so I think for some of the other questions, we'll try to just answer them in Slack, but just I've already spent about 15 minutes going through these, so we're going to move on to this stuff for the day. All right, let's pull up my notes real quick. All right. So a few things that you guys have probably seen floating around. One of them is the value undefined, and another one is null. We're going to talk a little bit about those. Open up a new Replit window. I'll zoom in. Okay. All right. So the first thing we're going to talk about is undefined. Okay. All right. So when I talk about types in the language, some of the different types we have, and you can test this with a thing that's called the type of operator. So you go type of, hello, and then print that out, and it's a string. 55, that's a number. 55 is still just a number. If it's negative, it's still just a number. If it's a really big number, it's still just a number. In other languages, they'll make distinctions between them, different types of numbers. But, so we have, we have numbers, we have Boolean values. Boolean, we have there are arrays, there are objects, there are functions, and so a bunch of different data types. So there's two more that I want to talk about today. One of them is undefined. So if you have a variable that has not been set to anything, its default, the default value is going to be undefined. This is not a string. This is actually, you can actually explicitly set things to undefined. It's not necessary to do that because it's initialized to undefined by default, but it is a type that the JavaScript language automatically sets to all of our variables and object properties if we have not set them to anything yet. So x is equal to undefined. Okay. There's another type called null. So null is kind of like undefined, but it's one that we have explicitly set. So the language by default sets things to undefined if they've never been set to anything. Null is a value that we'll set to a variable when we want to overwrite it. So maybe, so like, const user, here we have a user object, email. So we have phone number. And then, so we have their phone number on here. So let's say we wanted to go in and remove like this person's phone number, because maybe they moved or they're going to a different place and or they switch jobs or getting a new number and we don't have it, but we know their old number is invalid. So we'll set it to null, so we'll update it to null. So maybe in our database, like we found that the person's, they have a different phone number, but they never gave us their phone number. So we don't have a number for them, but we know the old one doesn't work. So we'll set it to null. And null means it's like setting it to undefined, but it's what we're doing after the fact. And so you never explicitly set things to undefined, but we can set them to null. Okay, so that's what null means, null and undefined. Another little kind of edge casey thing that you'll see is called not a number. So what happens if we take the number 5 and multiply it by the string hello? Obviously this is like a nonsense operation, and we get this value called not a number. So whenever you try to inject strings or if we have let's say like an undefined value, like let x, and we don't set it to anything. So 5 times x, that will produce this value called nan, which stands for not a number. So generally, if you're seeing a nan pop up somewhere, it's because you have an undefined value being plugged into a math equation. That's generally, or a math expression, that's generally what that's generally what's happening whenever you see a non bubble up somewhere or in an error. Okay. Funny thing about nan is, well, yeah, little side note, it's kind of fun. So the funny thing about nan is that it's actually not equal to each other, or equal to itself. So if I do const x is equal to nan, like that, so x is actually not equal to itself. So it's the only thing in JavaScript that's not equal to itself, which is kind of funny. And it has to do with like location and memory and all that stuff. But anyway, that's more just a little side thing to remember. Okay, so nan. So we've talked about nan, Undefined, and okay. All right, so now the next thing I want to talk about is truthiness. So, all right, so we've talked a lot about Boolean values true and false when using an if statement or another statement that expects a Boolean value. So for example, like an if statement is expecting, like it needs to, ultimately whatever is in between the parentheses needs to be evaluated to either true or false. So if I do, 5 equals 5, this expression ultimately evaluates the true. In fact, if I go down here and console log 5 equals 5, that's right here, this expression is going to be evaluated into a Boolean value, and it's literally going to turn into the Boolean value true before it prints out. And so that's what this is doing here. It gets turned into the true value. So what happens if I just put 5, if 5? So some values in, every value in JavaScript has a truthiness or a falsiness to it. So truthy values will get turned into the Boolean true when they need to get evaluated for like an if statement. So 5 is a truthy value, so it's going to get evaluated into true, and we see hi prints out. If I put a 0 in here, then it's going to print, we get undefined. So let me actually, truthy, and then we have falsy. Okay, so 0 is falsy because this one got ignored, went down here. Okay, and I put a return there too, so I don't hit the one down below. Okay, return outside of a function. Okay, I'll do an else. All right, so 0 is falsy. -1 is truthy, so all negative numbers are truthy. A string, so an empty string, is falsy. But if there's stuff in the string, it's truthy. An empty array will be truthy. There's stuff in it will also be truthy. An object will be truthy. Function will be truthy. Null is falsy. And undefined is falsy. So there's a table of this in your homework, and it describes this. But essentially, false, 0, undefined, null, empty string, those all get set to false. But then everything else gets set to true. And not a number is also falsy. So truthiness and falsiness. And again, this all kind of ties into, or just helps you better understand how if statements function in those logical expressions, how that works and gets evaluated, and it's important to begin to read your code in that way and see how these expressions evaluate and what the values simplify down to. Okay. All right, another little side thing we're going to talk about today. So again, some of the smaller things we're talking about, truthiness and falsiness. We've talked about null, undefined, nan, and then now we're going to talk about the arguments object. Okay, so here we have a function. Now I'm going to go invoke it. I'm going to pass a bunch of stuff into it. And so just a bunch of random stuff. And then in here, let's say I designed this function to where it could have a unlimited number of arguments, and the user can pass in as many as they want. Or let's say that I dynamically need to access all the different arguments. There is an array that is automatically created inside of every function that uses the arguments keyword like this. And it's going to be an array of everything that was passed in. So it prints out a little funny, and so it's looks like an object here. So this arguments array, it is an array, but it's it's an array that doesn't have all of the same methods on it as a normal array does. So you can't do push and pop on it. It's a lighter one. But it does give us access to all the stuff that's in there. So if we wanted to print out each item that was passed in one by one, we can do for let I get 0, I less than arguments.length plus. Okay. So again, this is just the standard line for iterating over an array. And I'm going to print out each item in the array one by one. So you see 1.5 high array object nan and true. So this is, I didn't have to create this anywhere. This is automatically generated inside of every function when it's called. Okay, you'll need to use this for one of the problems that you're working on today. Okay. All right. All right. So this now leads into some of the main things that we need to talk about today. The first one is it's a callback functions. So in JavaScript, we've seen how, well, with functions, we can pass them around and do a lot of interesting things with them. So in JavaScript, we can do stuff like const foo is equal to function. We do a function expression. We can assign a function to a variable. Is all valid syntax. It runs the function. We can put functions on objects. So we put functions on objects, and down here we can go object.foo. High print out. So a function can be on an object. It can be assigned to a variable. We could just define it by itself without it being in a variable like this. We can do const or so we can do itself. We can assign it to a variable. We can put it on an object. We can also put them inside of arrays. So I can find it inside of an array like this. All right, and then I can come out here and access it out of the array. So the first item in the array, and let me put down a little bit more. But so we have an array with a function inside of it. And so I can access it with a 0 index and then immediately invoke it. We run this, we see high, print out. So 4 different highs. So again, this syntax might look funny to you. This looks funny, but just showing the idea that functions can be in arrays, they can be put on objects, they can be assigned to variables. We're going to just have them by themselves. So functions, there's a lot of flexibility with what we do with functions in JavaScript. A new type of flexibility that we're going to talk about is that we can pass functions as arguments into other functions, and that's called a callback function. So here we have this function foo, and then what we can do is when it's invoked, CB, when it comes in, CB is going to be a function, and we can call it. So all a callback function is, it's when we're passing a function into another function. So foo right here is called a higher order function, meaning that it can receive a function as an argument, and then later it can even return a function, which leads into another discussion called closure and currying and stuff like that. But those are some things that we talk about in our main course. So again, this is a little more of an advanced concept, but the idea is that we pass a function into another function. So when foo is invoked, what it will look like is we're going to write a function like this, and it will be passed in. Right? So console.log hi, and we see it prints out. So again, so what we did here, we defined the function foo, and foo has a parameter that we're going to treat as a function, and we'll invoke it. So the later down here, when we call foo, we're passing in a function as the CB. So again, you think of a function as kind of like a template as it gets invoked. The parameters will be different depending on the arguments that are passed in. So you see here we've invoked foo again, but we give it a different callback function. See, hi and sub are both printed. So again, the main idea here, and the syntax might look a little funny because I'm defining the function in line like this, but all I'm doing is passing a function in, and then when the foo function runs, CB is the parameter that it uses to reference the function argument. Okay, so then we invoke it. So CB, when we call it on line 2, is calling this function the first time we call it. First time we call foo. The second time we call foo, CB will refer to this function. Okay. So Aaron's asking, or someone's asking, what's the practical use of this? I'll show you. And this is actually an extremely commonly used pattern in JavaScript. It's one of those where this doesn't make a lot of sense to you right now. You'll use it a million times, and eventually this will become second nature. So right now, this is a bit of a contrived example, so it's hard to see like what the use is of this. It's just showing that you can pass a function into another function. So now let's talk about some use cases of this. Okay. Let's see, and Aaron's asking real quick, can you set a variable value as a function? Yeah, so I can say const foo is equal to function like that. What I'm doing here is I have an anonymous function. So this is an anonymous function. It doesn't have a name on it. This right here is this is a function declaration that I have on this line, one on line 3. This one is a named function, and this one right here is an anonymous function. So right here I have an anonymous function set as the value for this variable. And then down here we have a named function. And there's a distinction between the two, and they behave slightly differently. Yeah. Okay. So one of the major use cases for using a callback function, it's with different helper methods on arrays. This is one of the use cases for them. So on all of our arrays, they have constant names. There's some people that work in our office. So we have an array of strings. We have 4 strings in here. And there's a built-in function on all arrays called for each. So this comes packaged on every single array. It's just like push and pop. Like not behavior-wise, but it's a function attached to an array. So for each, what it does, it takes a callback function as an argument. We pass in a callback function. And eventually, actually, this is how you're going to write your for loops. You're actually going to do this instead of using for loops much of the time in the future, at least when you're iterating over arrays. But for right now, write your for loops. But eventually, this is actually what we recommend. Instead of using for loops to iterate over arrays, at least if you're using a for loop for some other purpose, then that's great. But for iterating over arrays specifically, this is actually the preferred way to do it. So what we're doing here is the names array has a method on it called for each, and we pass it a callback function. And then what's going to happen is the callback function is going to be called multiple times behind the scenes, and then each name from the array is going to be passed in one at a time. Okay, so if I log out the name right here, we're going to see it print out. Ben, Austin, Karen, and Jocelyn all print out one by one. I'm going from left to right over the array. So this callback function that we gave to the for each, it's invoking it and calling it one by one. And yes, it does iterate in order. So left to right. So I can actually, the second parameter that will be passed into our function will be the I value. So I can print out the string I. Oops, have it. Save it. We see Ben is at index 0, Austin at 1, Karen at 2, Jocelyn at 3. Okay, so this is an example of passing in a callback function. Okay, let me just peek at something with our. Just real quick. Okay. All right. So let's check something real quick. Okay. So let's. Okay. All right, so this is how we can use array. So this is the for each method. So again, these are some things that this, like, you're just gonna have to write it a bunch of times, experiment with it, throw some console logs in, play around with it. But this is one of the use cases of a callback function, because we pass in a function, and this function is going to get called by the for each code. There's another one that's similar to for each. This is another array method, and it's called map. All right. And so this one, what map does, map is like for each, where it's going to iterate over the array, item by item, left to right. But then we can return a new value, and it's going to produce a new array. And then we can go in and take a look at that new array and change some things. So with modified names, so with names.map, we have this callback function. We get the name. And then what we can do is, let's say, return name plus exclamation mark. So we're going to add an exclamation mark to all the names. And then console log modified names. Print that out. We see Ben exclamation mark, Austin exclamation mark, Karen, Jocelyn. They all have exclamation marks. So what the map does, the map takes every item one by one, and it passes it. It invokes our callback function and passes it in. And then whatever comes out of our callback function gets put into the slot in the new array. Let me do a little diagram of that real quick. So essentially, from a high level, what the map is doing is, let's see, how do I? Sorry, 1 second. Before, just let me draw. Let me think about this. 2 seconds. You just pop this up and it's automatically set to it. Sorry, guys, 2 seconds. Let me see if I can figure out how to. I'm not sure why it's defaulting to that. Okay, all right. So something that it's going to do is, well, essentially all the items get passed one by one through this transformation function, and then the output gets stored into a new array. Let me check Google Hangouts and see if I can do something with this real quick. Okay. All right, we'll have to play around with that later. But okay, so essentially, like if I'll just kind of write this out. So what we're doing here is we're going to have an array. This will be the input. And then down here, we're going to have we're going to have a function. And then each item is going to get passed through the function, and then it's going to produce an output. So and so if it's our function up above, we'll see that it's adding an exclamation mark to each item. But essentially, it's all the inputs pass through the function. So whatever comes into the function is our inputs from our array, and then what gets returned gets placed back into a new array that has the modified value. So it passes the items one by one in through the array and then out the other side. Okay. All right, and this is something we so map. So these ones are, this is again is a little more advanced. These are some ones that that take some getting used to. It takes some time to to work through them. But these are the some major use cases of callback functions. So again, what the map would look like, behind the scenes, the map is going to look something like, if it has an array, it's going to be using a for loop. Well, no, I'll do it this way, but essentially it's using a for loop behind the scenes to go over our names array, and it's going to take each item one by one, and it's going to call our callback function with that item, and then we can go and modify it and append an exclamation mark onto the end of it. So again, this is one of those where you're just going to have to get in there and start playing around with it, and then and then we'll go from there. Okay. All right. So I mean, focus a little bit less on the idea of like using map and for each at this point. It's more the idea of seeing a use case for callback functions. That's the major thing to get from this. And again, there's also some explanations of this inside of the README as well. Okay. All right. So the final thing we're going to talk about is we're going to talk about classes real quick in a simple way. Okay. So in JavaScript and now in ES6, we have this new class keyword that we can use. So a class, you can think of it as, it's like a template for making objects. So in our, let's say in our application, we might have, let's say we have 1 million, 1 million users. And let's see, I see someone asking about that reduce. Yeah, if you want to look into the reduce more, you can go in and look in that inside of the homework instructions. We are going to pass on the reduce at the moment, just because that's you can use it to solve some of the homework problems, but it is not directly in there. So anyway, so you can check that out. That one's more on the side. Okay, so all right. So if we look at, so classes. So again, this is like a template that we use for producing objects, so like producing user objects. So again, if we have like 50,000 different user objects in our application, then the class is like the template that we're going to use for creating each one of those objects, and it ensures that they have the same format. So inside of our class, again, we define it with the class keyword, and then we have the name for the class. Convention is that we make this uppercase. We use an uppercase letter, and then curly braces, and then it has called a constructor function on it. Okay, so this constructor, and then so it's a little bit different of syntax. We don't use the function keyword anywhere, but this is defining a function on it. So the constructor, this is the constructor function on the class. This is where we can do the initial setup of the object that we are creating. So if we pass in, say name, well, user, so for a user, we'll say email and password. Email and password are getting passed in. So for this new object that we're going to generate, we're going to use the this keyword to reference it. So we're going to set an email property on the new object that we're creating, the new user object. And then we're going to set a password property. So email and password. And then we do this assignment. And that will set an email and password property on the object that we're creating. So again, the class is going to create an object that will have key value pairs. So the user object will have an email key with a password, or email key, that's the value of the email parameter, and then password likewise will do the same thing. Okay. All right. So now in this one, so now we're going to make a custom method that will be on the user class. So let's call this print email. And then inside of here, I'm just going to go console.log this.email. Okay. All right. So now so this right here will be a full template for creating a user object that has two properties on it, and then a print email method that prints out and logs out the email property from the object. So the way that we would use this, you'd say const user, and so lowercase user, so that's different from this. We're going to go new user, and we're going to invoke the class like a function, and then we're going to pass in the email and password right here. Okay. So the arguments here that we're passing in map up with the ones right here. All right, now if I console log user, you see here's the user object. Okay, so it has the email on it, and it has the password on it. Okay. You might think, well, I don't see the print email function on there. But we run that, and it does print out, it does work. And in a moment, I'll explain why we don't see the print user email on there, and it has to do with the object's prototype. So again, the key parts here, we have the new keyword that we have to use when we're using our class. and then we reference the class, we invoke it like a function, we pass in some arguments, and that maps up with the constructor function in here. So this is a new way of creating objects in ES6. This does not exist before. This is, they call it Syntactic Sugar. So this is, it's actually using the old way of JavaScript that gets compiled down into the old way. But this is the way that we're generally doing things. If you're using React, especially, you're going to be using a lot of ES6 classes for your components. So the new keyword, what the new keyword does, the new keyword in JavaScript makes the new keyword makes it so the way that the function runs, it behaves differently, and so so right now the main thing to worry about is it indicates that we're using the class to create a new object. The specifics of what it's actually affecting and changing in the language, it's different in JavaScript. It doesn't have anything specific to do with memory allocation. It changes the way that the constructor function is run, and it has to do with some stuff that's beyond what I want to get into at the moment. But basically, just right now, the main thing to focus on is that the new keyword makes it so we're using the class to generate a new instance. The main thing you can think of right now is that it makes it clear and easy to see, and it indicates that we are running we're using a class to create a new object. So again, a class is like a template, so we can reuse it as many times as we want to create new user objects. So I can do user 2, and this one has different email and password. And then I can come down here and do user2 dot email. 2 different emails worked. So what this is doing here again is it's a template that we use for generating these user objects that we'll use inside of our application. So classes are the templates that we use to produce objects. And you can use a class to produce lots and lots of objects. And so a user class is a very, very common use case. You'd have a class for a user. If you had some like e-commerce store, you would have a class for, store items that would have stuff related to, the transactions and prices, and maybe your add discount price method would be on the, a store item class or something like that. So those are some of the different use cases. I worked at a fitness company, and so we had classes for exercise equipment. We had classes for users. We had classes for data points on a map when they were doing different types of distance-based workouts. We had classes for workouts. We had classes for lots of things that were there were hundreds of different classes that we used inside of our application. And often the classes are tied to like if you're using it on the server, there, this concept of classes, it's tied in with a database. So you're creating new items and they get saved. But so inside of the constructor, inside of our class, this keyword will refer to the object that is being created. So anything that we want to put on the object that we're creating, we have to use this keyword. If I do this.hi, we run it again, we're going to see there's a key value pair of hi and hi. Then I can just have other code in here, and if it's not modifying this keyword, it just doesn't do anything. Like this creates a variable, and then we don't do anything with it, and it gets deleted. So it doesn't really do anything. Anything that we want to add to the object that's being created, we have to put on this keyword. Okay. Yes, many different ways to break this code. Does public-private access exist? Not directly in JavaScript. You can kind of mimic it with closure, but they're not directly public and private methods. So if you put user here, like user.email, that would add it to the actual class and not the object that's being created. And so there's a distinction there. So that would put it. So let me try this actually. If I did user.hi and then I console log uppercase user, the user class, we actually see that it added a property onto the class, the user class. But that's not what you want to do. You're wanting to add it to the object that's being created. So we see here that hi is on the class, and it's not on the actual user that was created. So there's a distinction there. It's like we put we put it on the template instead of on the thing that the template makes. It's like a factory. If there's like a factory that makes like users, it's like we just attach this to the actual factory. Or if you think of this as like a car factory, it's like we're passing in the parts right here to make the car. And so then we build the car in here and then we ship it out the door. If we do this, it's like we took the steering wheel and we put it onto the factory wall. And so it's on the actual factory, it's not on the car. And so the car shipped out and doesn't have the steering wheel on it. So, if you think of that as like an analogy of this function being like a factory that builds things, yeah, so you want to, this is how we reference the new thing that we're building on the assembly line as it goes along. So we're going to add the email to it, and we're going to add the password to it. And then this whole function here will finish up, and then we'll add the function to it. And then we ship it out. And then here's a new user that we just produced with our little factory on the assembly line. So that's how to think of these. So again, uppercase user is the factory, the assembly line. And then these are the new minted copies that have been produced. Cool. Awesome. Seems like that really stuck with people. Okay, so now last thing I want to touch on for this lesson today. So again, this has been a lot of little things that we've talked about, some of them bigger than others, like so callback functions and classes are a little bigger, but then there were a bunch of little things that we talked about earlier. So with the user class, you notice that the print email function didn't show up when we printed out, when we console logged a user or user2. And we see that on them there is no function, but when we invoke the function, it works. And so why is that the case? So what's happening here is that the print email function actually lives on the user constructor. So the print email function is actually going to live on the class, on this thing called the prototype. And so instead of taking this print email function and producing a new one for every user that we're creating, we're just saying that all the users can come back to the factory and use this one function. So it's like if there's a ton of code associated with it. So let's say it's like if we go back to the cars and manufacturing, let's say you need to get your alignment done. Instead of shipping all the tools to do the alignment with every single car and a jack and a lift and all that, to let's say like the lift to get the car up so you can rotate the tires. Instead of shipping that with every single car, all the cars can come back and use the one at the factory. Anyway, so it's a communist state and come back and it's free for part of it, right? But allocated by the government, I guess. I don't know. So it's we'll say it's a perk that the factory is offering, so they can all go back and use that at the factory. And so print email lives at the class. It doesn't live on the object. And so when we go user.print email, the program is going to look on user. It's not going to find print email, but then it's going to go look on the user class. We can actually go in and directly modify it. By adding functions to the prototype. That analogy fell a little flat. Okay. So this say hi function, we add it to the user prototype. And now what that does is that makes it so it makes it so that the say hi function is now available for all the instances of user to use. So it's not going to be directly on any of those user objects, but if we try to call it, then the user can go back and use it off of the constructor prototype. So this is a very, again, this is kind of like this keyword. This is kind of like a light intro into something that is actually a very deep topic. And there's a lot of stuff that we can get into here as prototype. This is one of the key differences between JavaScript and other languages, actually. And so JavaScript is a prototype-based language, which is very unique at the time, and it's something that initially created a lot of confusion for people coming to JavaScript over other programming languages. So people that would come in from like learning Java or C++, something like that, they would be kind of confused by this as something that's a little different and unique to the JavaScript language. So so the prototype, again, it makes it so this the actual say hi function is not on the user and the user2 object, but they can still access it. So it doesn't copy it. It doesn't. So if we had a million user objects that we created, there would still only be one say hi function in memory instead of a million copies of the say hi function. And they can reference this as well. And so this print email, behind the scenes, it's doing user.prototype.print email. So like this is what it's doing behind the scenes. It's adding it to the prototype of the user constructor. So again, this is a kind of a light, just lightly touching on this topic. So let me show you a cool thing you can do. This is considered bad practice, but it's kind of cool that we can do this. So arrays, when I say const names is equal to Austin, Ben, and whoever, just a bunch of names. Okay, so this array right here, behind the scenes, it's actually using what's called the array constructor. And so if you remember back from our previous example, we had user, which we used an uppercase U for, and that was a user class. There's an array class that is used for all the arrays that are created. So when you do this, it's automatically going out and using the array class to create the array. And so we can actually add stuff to the prototype that will be on every array that we create. So I can go array.prototype.say hi. So say hi. And so I make this array. Now I can go names.say hi. And we see hi prints out. Oh. All right. So we see that it all prints out. So what this does is this adds this function that all the arrays can inherit from. This is actually considered bad practice. Like you shouldn't go in and modify it. But this is me just demonstrating to you how that with this array prototype, we add a function to it and it makes it available to all the different arrays. And so that same concept, you can do it with the classes that you create. So like with users. And so, yeah, you're right. This is very dangerous. You would never actually use this. Like you never actually do this to modify the built-in ones because you could accidentally overwrite different methods or step on things, or if they update the array, like update JavaScript, and all of a sudden there's a say hi function, but then you've been overwriting it in your code, and to remove it would break 10,000 lines of code. I mean, it's yeah. So let's see. Actually, someone's asking if we set array.prototype to null. I love doing little experiments like this. I don't know what would happen, but let's. I think. Okay, so it still did it. So I'm actually. So it must have some kind of protection against that. But anyway. Oh, it must be. So yeah, still available. But anyway, fun stuff. So prototypes. So again, there's just kind of a light introduction into it. So does this using the arrays within the file or the entire project? it would use it within all of the, it would, so if I like did it right here, well, let's say I did it right here. Array dot prototype dot say hi. I can even just set it as a string. So if I print off names dot hi, this right here is actually going to be undefined. But if I move it up here, well, actually, let's say hi. So that says hi. Here, we see it still exists because it modifies it on the prototype. It's any code that would come after line 4 that wants to reference the say hi property would be able to go back up and reference it. So everything after line 4. So if in my file, so like your web application, maybe you have 20 JavaScript files, what happens at runtime is they all kind of get compiled down into one single big file, and just all the code after the line where you've written this would be affected by it. Okay. All right, so this is kind of a light introduction into the world of prototypes. So you will have to use the prototype. One of the questions asks you about adding a prototype method to a class that gets passed in, or a constructor. So in JavaScript, the terms constructor and class are kind of used interchangeably. So they mean kind of the same thing. JavaScript doesn't have a true class in the sense of other programming languages. So again, if you're coming in, from like a Java or C++ or one of those other backgrounds, classes are a little different in JavaScript. So the classes in JavaScript are more syntactic sugar. But anyway, fun stuff. Okay, so again, a lot of stuff we covered today. So we covered undefined, null, man. We talked about callbacks. We talked about for each and .map. In the assignment, it talks about another one. You treat this as a little more like extra credit, but it's called reduce. I skipped over that one. Just you don't have to directly use it for the homework. It's a little more advanced than some of these other ones, so but you can go in and look into that. These are super common, and when you get to the level of being like a real, like software engineer, you're using especially these three like all the time. So very, very common. Okay, and then we talked about class and prototype. So a whole bunch of different things today. And let me. Okay. Oh yeah, we talked about arguments as well. So a lot of topics. Okay. But good fun stuff. You can come back, review the video, ask questions in Slack. When we do this next month, we're actually going to break this out into 3 weeks, just because 2 weeks is still a little rushed for all the stuff that we're going to cover. So we're going to break it out and slow it down a little bit more. So anyway, feel free to. So when we do this again next month, some of the stuff was a little too hard this time. Practice it, come back, work through it again. We'll go over the material again and help you get this stuff down. Okay. Is there a way to check what all the constructors and their data types are in a class? If it's a class you created, you have to just look at the code for where you created it. If you want to go in and reference them on Java and on JavaScript, if you go to NBN, so this is the Mozilla Developer Network. There's a whole bunch of stuff in here. Like this is one of the best resources for learning about JavaScript. The stuff is written pretty clearly. They have great simple code examples. So come and check it out. So in here we can look at stuff like really the built-in classes in JavaScript that that you'd want to look at would be stuff like arrays and objects and yeah. Classes, you can look up more stuff about classes. You can look at the constructor. You have little playgrounds where you can do stuff. And so here's an example of an ES6 class. There's some more advanced behavior that we haven't talked about. Yeah, so check this out. Okay, so again, yeah, if any of you have questions about our full-time course, so how fast paced is the mini bootcamp compared to the full class? We get time to review or study during the day if we don't understand it immediately in the full class. So the full class, it goes from 9 a.m. to 5 p.m. Pacific time, so it's live and structured. So so a lot of it's fast paced. It's if you get the mini bootcamp stuff down pretty good, you'll be in a good spot for the course. But it is fast paced. We move at a quick pace, and we have a lot of material to cover in the 6 months. So it's pretty intense, but it's good because we push you and you learn how to learn. It's you get kind of thrown into the deep end, and it's pretty stressful for our students the first couple of weeks, but that's what it takes. Our student that we were talking to him today, the one that got a senior level job and never made more than $15 an hour in his life, told us today that he felt Lambda school was harder than his actual job as a senior level developer now, and all the coding and stuff he's been doing this last week. And says he finishes everything a few hours early, and they have to find things for him to do. And it's he's doing a great job. And so we go pretty hard, and it's and that is by design. It's not meant to be too hard and unapproachable and overwhelming, and we do everything we can to help you. We have TAs available, we have assessments that we give you, so that way we detect if you're falling behind, then we can give you some extra help so you can catch up with those topics. And so it's not like the documentaries of like the Navy SEALs where they're trying to like shouting in your face trying to get you to drop. So it's not that. It's really, really hard, but we're doing everything we can to help you make it through because because we want you to succeed. Someone's asking if that guy had a background in tech. He actually didn't. He had done a little bit of self-learning before coming in, but he did not have a technical background. Did not. I don't think he had a college degree. But he did not code or anything like that. Let's see, average percent of students who drop out due to difficulty or other life situations popping up. The average, it kind of depends on the class because it depends. Like, so last year when there were all the hurricanes and everything that hit, we had some unusually high dropout numbers just because people's towns were flooded or people didn't have electricity for 2 weeks or things like that. And so those ones had a little bit higher of dropout rates. A lot of them, we rolled them back to later classes. They didn't really drop out, but we rolled them back to a later class. And that happens sometimes. We'll have people that, like life circumstances come up and stuff happens and we get that. And so, we try to work with people. And so sometimes we have people that move back to previous cohorts. That happens more than people actually totally dropping. We don't get a lot of people that just have to drop. It's usually a pretty significant life event that causes that. But more people roll back. I don't know a number for a total dropout rate. It's for people that roll back due to other reasons. It's probably around 10% right now. So it's there's some people in each class that that do have to get moved back. 'Cause 6 months is a long time to be going at it. And initially we had a lot of people that would treat it kind of like college, where you skip class or it's a little more casual, and that just doesn't work. If people miss class for a few days in a row, it is extremely difficult to make that up. If it's like missing a class occasionally for like a dentist appointment, things like that, that's obviously fine and that's going to happen. But when somebody misses a week for some reason, that is extremely difficult to make up. Averages of homework. How many averages of homework? So so Thomas is one of our students, our current students. He's volunteering outside of class to come in and help answer questions. The first 2 weeks are pretty challenging. And we're actually probably going to shuffle them around a little bit just to make the beginning a little less. But it's really good stuff. You learn a ton. But it's a lot of fun. So the total hours of homework. So you shouldn't have to do homework outside of class. The first 2 weeks, some people will go in and put additional, some extra time outside of class. But uh, and the best students are the ones that are always hacking and working on little projects on the side all throughout the course. Those are the ones that do the best. But yeah, so you don't have to work outside of class. The 40 hours a week should be all of it, but for some topics that are harder for you, you may need to put some extra time in outside of class during those specific units. So we don't plan for you having to work outside of class. The 9 to 5 or the 8 to 5 p.m. But so we give you time in class to work on things. The amount of lecture time. So lectures, and there's different types of lectures that we do. So you're having live lectures every single day. Our units are broken down, so you're getting 2 units a week. So there's 2 topics, like 2 main topics that you cover in a week with a larger homework assignment. So 2 larger homework assignments. So that's in a week, but every day you're getting different types of like in the mornings we'll do code review, or in the mornings we do coding challenges, which are the same types of questions that you would get in coding interviews. So we go over those in the morning, and have solutions for that. And so you'll get a lecture in the morning. We go over like longer solution lectures to all the homework assignments. We have guest lecturers that come in and speak. And so we're going to be we're launching a data science and machine learning course that's coming up. It has a lot stricter entrance requirements than our CS course does, but we've had some different guest lecturers come in and present that may be teachers in that course. So there's been a lot of guest lectures on machine learning and artificial intelligence recently. But yeah, we just get industry experts to come in and talk about different topics. So that's a lot of fun. So yeah, just a lot of stuff like that. Try to totally immerse you in code for 6 months. Yeah, student teacher ratio. So we're hiring more and more TAs from our new classes that are graduating, and so that number is dropping. Yeah, I off the top of my head, I don't know the exact number, but it's somewhere between 10 to 20, like to 1 right now. As we get more TAs, that'll be hiring. The goal is to drop that down to about uh, about 8 to 1, I think, is what we're targeting. So that's dropping. But what we found is that larger class sizes actually create better communities when it's online. And so we make sure that we have enough staff on hand to answer questions and make sure everyone's getting enough individual attention. But we found that larger classes, when you're online, create better communities. Whereas that same class in a physical location would be unmanageable because there'd be too many people. And so we found that it's actually it's the students. There's a better community, and it creates a more fun environment when there's more. And so kind of some of those traditional barriers that you'd see, where like a class size of 30 people is more ideal for a physical class. It's different when it's online, and that's something that we've been experimenting with. And let's see. Methods for capturing notes on coding. Um, yeah, we upload everything that we do is recorded, so we upload that. Yeah, that's one of the main things. For writing notes, just use your code editor. Let's see. If someone finishes early, yeah. So if you finished your homework really early, yeah, you could go away. Step away from the keyboard. If it's something like Ideally, if you finish early, you're going in and working on little like side projects and things, or going back and perfecting code from before. Like that's more of an ideal thing that we would like you to be doing during that time. But yeah, if you get all your work done, then yeah, step away if you need to. Because it is 6 months. You want to think of it as like a full time job. It's like full time job. You're going to be there, all day, every day, 5 days a week. Who are the instructors? So we have a guy who worked for Blizzard, the game company. We have a guy who worked for NASA JPL. We have a guy who we beat out Oregon State for he was going to be a professor there. He's worked with game companies. He has advanced like blogs and like materials, computer science educational materials that are used by master's programs all over the world. We have just a lot of really fantastic instructors. Every single one of them would be at least a senior level engineer. Many of them, we have an ex-Google guy as well. Many of them would be executive level at other companies. So our most recent hire, we wanted him to come be a teacher for us, and there was another company that wanted him to come be the VP of engineering for them, and we beat him out. So it's some really highly qualified and talented instructors. Okay, part-time curriculum is exactly the same. It's just a year long instead of 6 months. Syllabus available. Okay, Austin posted the syllabus. I got to pick your instructor. No, so we assign it. And so the stuff that we're teaching, it's hard to find people that have mastery over the exact specific curriculum that we teach every single topic. And so some instructors will be better than others. So some are really, really good front-end developers. So like on our staff, the guy who's the Oregon State professor, he wouldn't feel comfortable teaching some of the React stuff. But then that VP of engineering guy that we hired, he was really good at some of the front end stuff like CSS and HTML and UI design and all that, but he doesn't feel as comfortable teaching React because he didn't use React at his last job. So he used Vue.js and some other stuff. So they all have these like overlapping circles of ability, and so we allocate them out based on what their expertise is, and that's how engineers are at every company. Okay. Yeah, so it'll be about 50 is the max size for a class. But we found that has a better feel than 30. But then we'll divide them out into subsections because we don't want it to be we don't want it to just be a madhouse. We don't want people to be lost in there. We want to make sure that everyone has that, that they feel that that individual touch, and that one-on-one experience. How many projects will we've completed by the end of the program? Yeah, so you'll have some different so some personal projects that you'll be doing, and then also a team capstone project that you'll do at the end of the course. That's the main one. How many programming languages do you cover in the program? So JavaScript is the main language, but then we also cover JavaScript and C are the two languages we spend the most time in. But then we also cover some Python and Go. Those are more of just getting you familiar with multiple languages and how the syntax spreads across different languages and some of those paradigms. But C and JavaScript are the main ones. So you will be a JavaScript expert by the end of it. So you will understand JavaScript thoroughly, expert level. You'll understand C pretty well. The main idea with that is to help you get a better understanding of the fundamentals. Let's see, February spot's still available. I think it's full. Message me and Austin. I need to check with our admissions person just to double check. So if you want to get into February, message DM me or Austin, and we'll double check and make sure if we can fit you in. But we do have spots open in March. So March for sure has some spots available. Would we be able to make a portfolio of our projects during the course? Yes, yeah, you'll have a portfolio. Awesome class so far. Thanks, Jennifer. Yeah, glad you're enjoying it. Are there mock interviews? Yes, we do tons and tons of mock interviews. We do lots of like whiteboarding stuff. Especially towards the end of the course. All the coding challenges in the morning are like kind of like mock interviews. We have several people on a career development team. We go over resumes. We help you write resumes. We go over job application strategies. We polish your online presence. We teach you interviewing soft skills, so that way you can only knock it out of the park once you get in front of them. We teach you negotiation tactics, so once you do get an offer, then how you can maximize it. So we do like group whiteboarding sessions, things like that. And we'll teach you like seriously just the negotiation fundamentals are honestly one of the most valuable things we'll teach, and it's amazing how with a few good negotiation strategies you can it's free money on the table. That's one of the most valuable things we teach, honestly. What kind of projects should we do after the mini bootcamp ends? I would say go learn a front-end library like either React or Vue.js, or you could go learn jQuery, and then just try to build things. Just keep just keep trying to build things, and then that's the main thing. The students that do the best are the ones that are always building things on the side, because that really strengthens their knowledge of the fundamentals and makes them very comfortable when they get in interviews. Requirements for the ML course, how the curriculum on the site. I'm good with R, MATLAB, but new to JS, Python. So that's still being solidified. I'm pretty sure that you have to have taken calculus. So there's some math requirements, and we'll have some different online things available that you can look at. So if you want to go and learn those fundamentals, but there are some math requirements, and then Python will be the main language, I believe. That's still a bit of a work in progress. We're still finalizing it. So JavaScript is one of the most in-demand programming. Actually, it is the most in-demand programming language. There's more jobs for JavaScript than any other language, I'm pretty sure. You can use it, and the reason for that is because you use it. It's the only language you can use for front-end web application development, but then you can also use it for mobile app development. You can use it for back-end development. There's tons of ways you can use it. It's a very powerful language, but it's also simpler and easier to learn. So that's why JavaScript is where we start. And it makes it nice because we can make you masters in JavaScript and then teach you how to develop on a lot of different platforms. Is JavaScript going to be used in 10 years? It's really hard to predict that. It would be hard to say that about many languages. I would say yes, because I don't see JavaScript getting replaced in the browser. Right now, JavaScript is trending up. So like Ruby is trending down, PHP is trending down, but like using Node Express on the back end for like server development, that's trending up. React apps or like React Native apps, which uses JavaScript for mobile apps, that's trending up. JavaScript is very much trending up right now. And so it's a very safe bet as far as a language goes to learn right now. But the thing is, the principles are broadly the same, and we teach you that during the course, and so you'll have the flexibility to go and learn another language. So if we teach a little bit of Python, if you wanted to go master Python and build Python Django backend applications like server stuff, you'd be able to go and do all of that. You'd be able to go and pick that up because you understand the fundamentals, and that's what programming is, because the landscape shifts and changes so much. You have to be flexible and you have to be able to learn fast, and the principles are very similar across lots of languages. Yeah. How's Java doing? So Java's used for lots of stuff as well. I think for like backend like applications, it seems to be trending downward, but for mobile apps, that's one of the major use cases now, because Java's used for Android apps natively. But yeah, Java and C++, they'll be around for ever. Or they're not they're not really going anywhere. But yeah, used for different types of things. Like like C++ is what you'd use for hardcore game development, but you're not going to use C++ to really make mobile apps, or you're going to use C++ for websites or servers, things like that. And with backend applications, there's so many different languages you can use. Java and C# and Node and Python and Elixir. There's tons of different languages and frameworks and tools. So you do lots of companies know about Lambda School, more and more. Our first class just graduated, so it'll take a little bit more time for that word of mouth to spread. But it's we have over 75 hiring partners. These are companies that we've that have expressed interest in hiring our graduates, and we work with them to for internships and different things like that. And so some of those include IBM and PayPal and Sling TV and Slack and U.S. Air Force, a bunch of others. Yes, yeah, hiring partners have hired. I've hired graduates, and we'll be releasing more transparent reports on that. All that information with like average salary right now with the people that have been hired is I think it's 82,000. All of our graduates they're outside of a lot of the major metropolitan areas, at this point. Not totally, but just so like some boot camps are like only in San Francisco, and so they'll have a pretty high like average salary, like like 104 around there. But if everyone's living in San Francisco, the cost of living is significantly higher, and so that skews it quite a bit. And so for example, a mid-level, a kind of junior to mid-level engineer is going to be getting anywhere from like 90 to 110 in San Francisco. That same engineer in Utah will be making 60 to 80. After taxes and cost of living, that 80,000 in Utah is going to go a lot farther. You're going to have more money actually at the end of the month than you would with 100,000 in San Francisco, which a lot of people they really underestimate the cost of living difference. All right, I guess I can actually do my face instead of you guys all look at the MDN page. Schedule for information requirements for the part-time class. I think we can post that in a minute. If you head to our, on our website, there's a part-time page. I'm pretty sure it's up there. We just started a pilot course for it. So it's the very first one with 30 people. We started that in January. And so we'll be launching the next course of that in July. It's the exact same curriculum and syllabus. It's just going to be a couple days a week. And yes, new haircuts. I was getting pretty shaggy and had to cut it off. Yeah, the Bay Area is insanely expensive. I live out here too, and have a family, and it's it's crazy expensive. It's 5 or 6 times more than we were paying before we moved here. What kind of projects am I working on right now? An attendance tracker. We're building out an automated attendance tracker for all of our students. It's we've had an MV, like a basic version of it. We're building that out. Working on some different school related projects, which is pretty fun. And thanks for the compliment on the haircut. So fun stuff. A lot of our students stay on as TAs as well, and some of them will have a chance to come in and work on our code base too. And so that's something we do a lot of, as well as we want to do everything we can to help students succeed. And so so many of our students right now, our graduates, are helping out as TAs while they are continuing their job search. So we can pay them and help them out financially while they're continuing their job search, and then it helps them to strengthen their skills, and then the current students get the benefit of getting more help from more TAs because they're all at a very, very solid level. Do you need a webcam to attend, or is a microphone enough? A microphone's enough. We'd prefer you to have a webcam. Is the part-time program as fast-paced as the full-time program? No, it's instead of 2 topics a week like the full-time class, it's 1 topic a week, and then it just goes for a year. Oh, well, thanks, Megan. So it's fun. We love teaching. We're passionate about this, and it's most of our instructors have taken pay cuts to come work here. And the reason for that is it's one of the most satisfying things in the world to see someone who, we just saw we just helped a poor, Haitian, immigrant, go from, he's been here for a long time, but, never made a lot of money in his life. And, and now he's, working at Uber, as a mobile engineer, coming from a non-technical background, and just seeing that total transformation in his life and seeing how that's going to affect him, and, and just seeing his humility and his gratitude, and seeing how that's going to affect his kids and his family, and taking someone from a poorer, and from a societal perspective, less productive state into a very high skilled, high output position. That just does so much good for so many people, for him and his family and his posterity and all of that. And then it's good for Uber. They have another engineer to write more code, and it's and it's good for the economy because now it's there's more money flowing out from Uber through that engineer out into the place where he lives. And it's such a positive benefit on the world, and it works because we make it free. So we still get our tuition payments, so we can grow and teach more students and grow and have a good business. But then the students are happy to pay the tuition because then they have a job, and so they don't it's not being reversed, and you're making an investment in us and taking a risk on us. It's we're making a financial investment directly into you and taking a risk on you. And so it's kind of flip that. You sacrifice your time, you invest your time and your opportunity cost, but we're the ones that are investing financially into you as a student. It costs us. We're spending millions of dollars. Like you'll come in and and you won't have paid anything, but we will have paid thousands and thousands of dollars for every single one of you. In teacher pay and in materials and all of this stuff. And that's the vision of the company, is that we are investing in you as students. And then when you're successful, people are very happy to pay us back the tuition when they've just seen a huge increase in their in their income. Because if we take someone from $15 an hour to making an $80,000 a year, they're more than happy to pay us a percentage of salary for a few years, and then they get to keep that $80,000 a year job, with raises and everything, for the rest of their life. And it's worth that investment. The ROI is huge for the student. We ever get into elementary and secondary schooling? We would like to see eventually down the road, more of a path where we're seeing high school graduates, or high school dropouts even, coming in, doing our course, trying to encourage them to coming and doing our course. But right now it's mainly focused on, most of our students are people who just, some of them went to college and they just, don't have a job that they like. They want to get into something they enjoy more, or they never went to college and they're just, smart, hardworking person, but just due to life circumstances haven't been able to, afford to go to school for 4 years. CD Lambda School t-shirt if you enroll. Yes, we give Lambda School t-shirts to our students when they graduate. What background is suggested for AI data science bootcamp? I'll have to get you more information on that. Basically, just if you've done some math, so calculus specifically, because we get into some math heavy principles that we have to go over. So that's one of the big things. But then some basic programming. So I think they're going to have some basic Python for the pre-coursework, kind of like what we're doing now with JavaScript, but they'll do all that with Python. Because Python's the main language used for like data science and number crunching and all that. Let's see, how much of a pay raise do computer engineers get on average? So software engineers generally, I mean, it depends on the company. Most companies offer some type of a cost of living raise annually. See, Thomas, you'll get your shirt when you graduate. So, yep, we will have you one. We're actually just printing new shirts, getting that all figured out. So CS1 they haven't gotten their new shirts yet, but they will soon. Let's see. So when you're in the market, what kind of raise do you get? It totally depends on the company. If you do really, really well and work super hard, the biggest raise generally comes when a year or two in, you go and you switch jobs. And then when you switch to your new job, you're able to negotiate for a much higher salary. That's usually when a lot of, bootcamp grads see a big jump in income. It can be hard to get that first job, but then once you're in, you're pretty much set as long as you can just, hold your job for a while. Most people, really succeed and do well. So, and that's why we moved our class to 6 months, because we wanted, we want every single one of our students to get a job, and we want them to not only get jobs, but excel and to be, referring and hiring our future grads. We want it to be that our students are so good that they are all senior level engineers 2 years after graduating, and then they're going to come back and hire, Lambda School grads from future classes. Yeah, and everyone will ask for Half-Life fans. Yes, every single Facebook ad we get like 4 or 5 jokes about Half-Life. So we have a new designer. We're working on some different logos. This one was one we kind of threw together real quick, and it's almost the same font as the Half-Life logo. Let's see, is there a demand for jobs in this kind of work? Yeah, so despite the okay, so I know in Utah, let me pull these specific numbers real quick so I can tell you the right number. I'm from Utah, so that's why I know a lot of their specific market numbers off the top of my head. Yeah, so there were 400 people that graduated in computer science in 2017 in Utah alone, but there are 4,000 open tech positions in Utah. So there are 4,000 open unfilled tech positions in Utah, and there were only 400 new computer science graduates. So that's just in Utah. Around the country, that's there's I think it's several hundred thousand, if not a million, open tech positions, and it's anticipated to be even worse a couple years from now, because you have all these tech companies that are growing and getting larger and creating more and more jobs within this space. But there's a huge growth in this sector and huge demand, and these companies need more engineers so they can continue to grow their product. But it's it's hard because they don't. There's the universities aren't very elastic in increasing their production of computer science graduates, and so that's why boot camps exist. And we're trying to fill that spot between a degree and a boot camp, because boot camps generally just miss a lot of pieces, and so that's why we're 6 months and we focus on CS fundamentals. Yeah. Yeah, the April cohort is the pilot group for the machine learning and data science course. So that'll be the first one. Have any of the students and graduates done freelance work while job searching? Yes. We have a few that have done that. In fact, I helped one today negotiate his contract rates with the guy he's contracting with. Has outsourcing been an issue? I'm not sure entirely what you mean by outsourcing. Maybe you mean like helping people find jobs or find companies to interview with. It depends on the student, the market they're applying to, the companies that they're sending applications to. There's a lot of factors that go into it. Um, Naturally, someone with a bachelor's degree it'll be a little bit easier for them to get in the door at a company to interview. It doesn't mean that they're going to be better than the other Lambda school graduates. It just it helps them get in the door a little bit better, and that's something that most of you can't control, but it's fine. And so that's we've already had people without college degrees get jobs, and so it's just one of those things that maybe will make it like a few percentage points more difficult. But yeah, there's a lot of factors that play into it, and if you work hard and build out a really solid portfolio, those are the most important things. And you will get rejected from a bunch of jobs. That's just how the process goes. Like, you will get rejected. That's fine. You just let it roll off your back, and you get better at interviewing. You become a better engineer. You keep practicing, keep studying, and then eventually you'll get something. We're planning to have more part-time classes in the near future. So officially, the earliest is July. Unofficially, off the record, demand is really, really high for it. So we're exploring the possibility of launching some sooner. That's off the record, unofficial, but I guess it's being recorded on YouTube and will be up there so everyone can see it. But anyway, officially on our site, July, that's when we're going to launch the next one. But we are exploring the option of launching some sooner. What is class structure like during the 6-month program? It's 8 hours a day, 5 hours a week. Is there time allotted for breaks? Yeah, so you have like a lunch break that'll be an hour long every day. You'll have there's like lecture time. There's time where you're working in like in pairs on your projects. That's a lot of teamwork. So there's a big variety. There's guest lecturers that come in. It's coding challenges that you do on your own, and then we'll have coding challenge reviews and solution lectures, and a bunch of different things all scattered throughout the day. So we try not to have you just like sitting in a lecture for hours and hours and hours. We try to break it up, but then we try not to have you just like on your own for hours either. So we try to mix it up. Let's see. Yeah, outsourcing software engineers outside the US seems to be slowing down. Yeah, it's just there's trade-offs. If you outsource your coding to another country, there's risks involved. If you hire someone within the States and they can be in there face to face and you can work with them, then there's other pros and cons there. So it depends on the company and what their budget is and what they're willing to do. And generally having your own in-house engineering team is the more ideal solution. So let's see. It's not important if you have a CS degree or not. The only thing you need is to know how to code. I have a bachelor in law and no experience coding any tech background. It really is up to your effort, and it's up to your like portfolio. So if you can demonstrate that you know how to do it, it's very much a meritocracy. A CS degree will help you get your foot in the door, and a CS degree is great. You'll learn good things from it, but it's expensive and it takes 4 years. So it's about trade-offs. So if you want to do that for several years and work through it, then you'll learn some good things from it. Some things that we don't have the time to teach in 6 months. But we feel that we're able to cover all the key points that are the most important topics out of a CS degree, while also being very practically focused. And that's stuff that any CS degree, really, to my knowledge, some kind of have some more modern stuff, but it's hard for the universities to really keep up to date on what the market is currently doing. So again, I can't speak for every school, obviously, but that's the that's the trade-off. I personally believe that if someone were choosing between a CS degree and our course, if they did our course, finished it, got a job, 3.5 years of work experience plus our 6. Well, we'll say it takes them 3 months to get a job. So 3 years and 3 months of work experience plus 6 months of our course, and 3-month job search. They're going to be in a significantly better spot than someone who does a 4-year CS degree. They're going to understand everything that the CS grad would know. They'll also will have made money during that period. They'll be more experienced in a more senior position, and they'll be on a much higher trajectory. While the CS grad is maybe looking for an internship. So that's how I see it. Some people might come and want to fight me on that, but yeah. Do a lot of applicants get rejected? If so, why? One of the things that we have to really teach is are the soft skills. Being really good at the soft skills for interviews. We've had applicants get rejected for that. Sometimes it just depends on the company because every company interviews differently, and it's a lot of them use very imperfect interview processes. And so the big thing with our grads that we have to overcome is we have to be able to get them into a position where they can show what they know. And oftentimes they'll get rejected before they even get to that point. But if our graduate is able to get in front of an interviewer and write code, the consistent feedback we hear is that they're phenomenal. But they have to be able to, the guy who doesn't have a degree and comes from a poorer background, and we have to make sure that he has a solid resume and make sure that he has the soft skills to be able to get in and show well, so that way he can get into a position where he can actually write code for them. And once we can get them to that point, then it usually goes pretty well. But but every company is different, and every applicant, will, the first couple, were, one of our star students, they didn't really get rejected at all. But then, some of the more recent ones who've received offers, got rejected from the first couple of companies they interviewed with. And that's just part of it. That's how I was when I was first going through my job search. I, got rejected from a bunch of companies, but then had a bunch of other offers, so it just depends on the company and how they look at it. Yeah. Yeah. So, so I have many friends who, who were not programmers, before coming through a boot camp, and then I've gone out and been able to do it. What is the acceptance rate into your program? It fluctuates, right? It's been as low as like 2%, but then it's right now it's about 5 or 6%. A lot of that is like you have to be qualified to work in the United States. So international applicants, for the free upfront at least, we can't accept you at this point. We are working on expanding, into other English-speaking countries first, and then, looking at some different internationalization options. And then a lot of it is, can you make it through the pre-course work? That's a lot of it. Like if you have the discipline and the ethic to be able to, work ethic to be able to make it through the pre-course work, and it can be really hard, but if you can seek help and be able to make it through, and complete the pre-course work, that's the big gatekeeper. So if you can do the pre-course work, then it's a 95% chance you'll get in, if you can complete all the pre-course work. That's the big, like, we don't want to reject people. We have to filter for people who are committed, and can complete the work. And I admit it's an imperfect process, but we have to start from somewhere, and we're working on making it better. But we don't want to reject people. It's not like, again, if I go back to that Navy SEAL analogy, we're not out there trying to get people to quit or get people to drop it. We want everyone to make it through, but we can't sacrifice the standards, and we have to make sure that people are coming in at a high enough level to where they can keep up with the fast pace. So to make your application stand out, honestly, say you're doing the mini bootcamp. If you're doing the mini bootcamp, going through these classes, you're a week in and you're still doing it and going through it, that stands out. And if you're in this spot, if you're finishing the pre-course work, and just write thorough answers on your, so many people send in applications where it's like a 2-word answer in the fields, and like we don't even look at those. So you have to like put a little bit of effort into the application. That makes you stand out too. Those are the big things. Just be nice to the interviewer. She's on a lot of phone calls, talks to a lot of people. So those are the main things for getting into the program. We want to be able to help as many people as we can, and so just complete the pre-course work, and and don't be a jerk, and then you're pretty much that's 95% of the way there. So it's yeah. That's the main thing. We're opening the pre-course work is we found that by letting the people work on the pre-course work is a better way for us to filter them by just giving a coding challenge or doing like a little pseudo IQ test kind of a thing, just because that's not nearly as effective of a filter. Let's see. Do we still do the Udacity stand for CS1 pre-course stuff? We list that sometimes. We list that as a reference that people can use to learn in addition to our lecture videos. So it's another resource they can go use to learn the fundamentals. But this GitHub repo is the pre-course work now. And so everyone's just going to work off of this stuff. Yeah. So we've changed it. We've actually made the pre-course work a little bit easier, just because it used to be a little too much. You might be thinking easier. Like this is already pretty hard. It used to be pretty insane. So we've kind of toned it down a little bit, and just overall, we probably had things a little too difficult, and so we've kind of toned it down a little. But without sacrificing quality. The idea is make it more high quality, go at a little bit slower of a pace. That's why we're going to 3 weeks next month with the mini boot camp. So that way it's a little more gentle of a ramp up, just because today, like classes and all that stuff, I could probably be broken out into some different lessons. Yeah, the extra credit isn't required for this. That's more like stretch stuff. If you can do that stuff, then you'll be in a better spot for day one. Because we have some students that just blow through the pre-course work because they have more of a technical background, and so they just fly through it. And so for them, focus on the extra credit stuff, because then you'll be in a better spot to really do well the first week of class. But for those of you that it's a challenge to even finish the basic stuff, just do that, and then you'll be fine. We try to make it a little bit of a buffet, to where there's lots of stuff for everyone at all the different skill levels can all come in and use it. Any classes you can take before doing the pre-course work to have a better understanding? There's in the README, there's a Udacity course that's listed that covers basic JavaScript. That would be a good one to check. Pretty much the more JavaScript you can learn between now and the start, the better. So every resource you can do on JavaScript, the better you can get with JavaScript, the better. Like focus on that, because that just ties into all just basic programming. Like you learn so many just programming fundamentals by getting really, really good at one language. And so focus on that. And I'm moving my hang up things, and I'm actually like looking where the camera is. So focus on JavaScript, and then that will put you in a good spot to be able to really hit the ground running on day one. The biggest thing that causes people to fall back is just struggling with JavaScript. Okay. Awesome. Great questions, everyone. Great class tonight. And we will go over solutions and homework and stuff tomorrow. So thanks, everyone, for attending. It's been a lot of fun. And we're going to be doing H2. So change of pace. Tomorrow's homework will be significantly easier and more gentle than what we did today. In fact, today's the hardest day of the whole mini bootcamp. So like today's stuff is hard, so don't stress about it too much. It's hard. And then, the next couple days, it'll be HTML, CSS, and JavaScript API stuff, which is a little more fun, a little more, yeah. Let's see. Actually, wait, Thomas is saying there's another question about Lambda Labs or something. Yeah, and you have to finish the pre-course work before the start of the class next week. So it starts next Monday. So you just have to have it done by next Monday. So especially if you are in the class that starts on Monday and you're stuck on stuff, make sure that you message me or just message for help. If you're getting stuck and you're wanting to start on February 5th, especially tonight. Tonight's assignment's a little extra hard, so if you're getting discouraged tonight, like that's normal. Just work through it, do your best on it. If you have to get help on every single problem for tonight's homework, that's totally fine. Thomas is here doing a lot of volunteering, so hit him up with questions. He's been fantastic. He's a great student in our course and really knows his stuff. Let's see, Thomas, I'm actually not seeing where it's in About Lambda. Oh, I'm sorry. I'm not looking in the About Lambda channel. Let me let's see, asking about equal opportunity and program acceptance for poor marginalized people who are not merely underrepresented in tech, but completely unrepresented in tech. Poor disabled, lone learners, job seekers over age 50, poor marginalized, and trafficking survivors, etc. Yeah, we keep the process as blind as possible. Yeah, it's we try to keep it racially and gender and age blind as possible, it's purely based on the merits of the application. And so there's things there, looking at the data, there's things that we can do to optimize that, improve on that, and we have some people we've been working with to to improve that, because it's something that you always want to get better at. But we are significantly over-indexed towards minorities, and specifically as compared to the relative population as a whole, within the United States at least. So yeah, good questions. And that's we see ourselves as mission driven, and we're wanting to that's why we use this model, and we get a lot of people that apply and do our course that wouldn't be able to otherwise. And yeah, so let's see, lots of fun. I think some of the people asking about that are not actually in this video call, but okay. Thanks everyone. Have a great night. See you guys tomorrow.